So in this lesson, we're going to look at the two properties of work and power. So I'm going to go through each of these and just explain what they are. So the first one we're going to look at is work. So traditionally, you might think of, okay, somebody gets a job, they go to work. But in physics, it's much more specific than that. So work, basically, it relates to force and it relates to distance. So basically what work is done if a force results in an object moving a distance. Okay, so that's what work is. And this here is the formula for work. So work is equal to force multiplied by distance. So work is equal to force multiplied by distance. And we have learned about force already. Okay, so we know that force is in newtons. Okay, so newtons, we measured in newtons. And distance is measured in meters. So when we combine the two of these together, we get what are called Newton meters. So it's just like this. So 1 Newton meter. And 1 Newton meter, what we use for that, the word that we use for that is just 1 joule. So 1 joule. So 1 joule is equal to 1 Newton meter. So this is essentially what makes up work. So you can, if you think about that, if you try and bring that into your everyday life. So when are you doing work, for example? Well, if we, for example, imagine we have a table here and we have a cup on this table. Okay, so this is a cup and it starts here. Okay, so we apply a force. So we pick up the cup and we move it and we, let's say, put it here like so. So what we have done there is we have done work. To calculate the exact amount of work that we've done, so how many joules of work we've done, so we need to know two things. We need to know the force. So we need to know the amount of the force in newtons. And then we need to know the distance that's moved. Okay, so the distance that the object has moved. So that's an example of work being done. Another example of work being done would be if a person was standing like so and they had a ball in their hand, for example, and they just let it drop. So you have a force, okay, the force of gravity, okay, and you can get a measurement of that in newtons. And then you have the distance that the ball dropped in meters as well. Okay, so again, that's what's known as, when we talk about work, they're like the two kind of examples of what we mean by work. And then just very briefly to talk about this other property, which is called power. So power is really talking about, so we're taking this quantity of work and then we're adding in a time dimension into it. So power is the work done over a period of time. So the more work that's done over a period of time, the more power there is. So the unit of power is, if the unit of work is the joule, then the unit of power is going to be the joule per second. So a way to kind of think about that is, let's say you had, okay, so you had a weightlifter. So you had two weightlifters side by side, like so. Okay, these are my really bad drawings of weightlifters. So you have two weightlifters like so. And imagine both of them, so that they have the same weight. Okay, so let's say let's say it's 20 newtons. Okay, and they're moving it up and down. The same distance. Okay, so imagine they're able to extend it up and down 1 meter. Okay, so they are both doing the same amount of work. Okay, so the work is going to be 20 multiplied by 2, which is going to be equal to 40 Newton meters. Okay, so 40 Newton meters. So that's 40 Newton meters, or they're doing 40 joules of work. Okay, now imagine the difference. So imagine this guy here was doing it in, let's say, it took him 2 seconds. And this guy, he was taking 4 seconds. So he was struggling a little bit more to get it done. But this guy was getting like a rep done every 2 seconds. So he was able to do this rep in 2 seconds. And this guy was able to do the same rep within 4 seconds. This guy over here is more powerful. Why is there more power? Because he's able to do the same amount of work, 40 newtons, but in less time. He's able to do it in 2 seconds. Whereas this guy, he's able to do the 40 newtons of work, but 40 newton meters of work, or 40 joules of work, but he takes 4 seconds to do it. So if we look at power on both sides, so this guy is taking, so it's going to be 40 divided by 4, which is equal to 10, and the unit that we use to represent power is watts. So he is converting, so like he's doing 10 watts of his power is 10 watts. So, and if we look at this guy here, so again he's doing the same amount of work, but he's doing it in less time. So his power is 20 newtons, or sorry, 20 watts, should I say. So the watt is basically joules per second. Okay, so this guy is doing 40 joules per second, 40 joules per 4 seconds, which is 10 watts. Another way to think about that is it's 10 joules per second. This guy is doing 40 joules in 2 seconds, which is 20 joules per second, or 20 watts. So that's just and power. So power then, the formula for power is going to be equal to work divided by time. Okay, so that's the definition of work, and that's the definition of power. So that's what we're talking about here. So just to kind of recap, and then we look at some examples. So work and power. So work is done if a force results in an object moving a distance. Unit is one. So basically the unit is in joules. So a joule basically is 1 Newton meter. So it's applying a force of 1 Newton over 1 meter. The unit then is what's known as a joule, which means a Newton meter. The formula is work is equal to force by distance. The force is going to be in joules, sorry, in newtons, and the distance is going to be in meters. And then power then is taking work and adding the time dimension. So power is work done over a period of time. The unit is the watt, which is a joule per second. So power is work over time. The unit for it is 1 watt. So 1 watt is 1 joule of power every 1 second. So you're converting energy from one form into another. So just to kind of get this idea of work done. So remember, work done, in order to get some work done, we have to apply a force. And that force has to make an object move a distance. Okay, so if we have a look here, so we have this guy here, and he's trying to move this filing cabinet into the house here. So we can see there's a distance. Okay, so from there's about 10 meters distance from where the filing cabinet is until to where the person's house is. So in order to get this filing cabinet to move, a force has to be applied. Now, enough force has to be applied in order to make it work. If the person applies force, so for example, so we can see here, okay, if we have a look down on the left hand side, so we see here there's a force being applied, but the object isn't moving at all. So there's no work being done. Even though you have the force being applied, in order for work to be done, the object has to be moving a distance. So in order to do some work, we have to apply more force, and we can keep applying force until the object starts to move. Okay, so we have to overcome the force of friction on the ground in order to get this object to move. Okay, so now we can see that the object is starting to move, and depending on how far we push it, how far it moves, we will have done some work. So remember, we can see that we're applying a force of 654 newtons, and we can see that we have moved the object. Let's say, so we've moved it even more than 10 meters. So what we can see is once the object starts to move, we're continuing to do work. So that's like an example of what we mean by work. So work is basically force applied over a distance. If the object doesn't move, so if you're pushing on an object, for example, if you're to push against the wall's not going to move, so therefore no work has been done. Force is being applied, okay, so there's so many newtons of force being applied, but because the object isn't moving, there isn't any work done. So in order to do work, you have to apply force, and the object has to move a particular distance, and then you can calculate based on, so work is going to be force multiplied by distance. And then if we, so for example, if this person is able to push the object the same distance, apply the same force, push it the same distance, but do it in less time, okay, he's going to be more powerful. So power then is including this dimension of time as well. So it's work done over a period of time. Okay, so let's look at some examples of calculations that you could be asked to do when you're dealing with this property of work. So again, the first thing we'll do is we write down our formula. So work is going to be equal to force, and remember, force is in newtons multiplied by distance. Okay, so force is going to be in newtons, and distance is going to be in meters. So remember, always make sure that you're using the correct units, and therefore this is going to be Newton meters, or what are known as joules. Okay, so they're the units that you're going to use. So let's first of all have a look at this table of information, just to kind of see the pattern between that you get in relation to the pattern between force and distance. So we can see here, if we have a look, so this is just a table of results that a student would have calculated. So we can see that we have, so when the force is 20, the distance is 5, so therefore the work done is going to be equal, so the work in the person is going to be equal to the work, so the force, which is 20, multiplied by the distance, which is 5, which is going to be equal to 100 joules of work. Okay, so that's, you can see here, this one here. So the next one then, if we have a look, and I'm just going to do one or two of these. So again, we have a distance of, so we have a force of 17.5. So work is going to be equal to, so it's 17.5 newtons multiplied by the distance, which is 10 meters, and that's going to be equal to 175 joules of work. Okay, and the same pattern holds true then for all of this data here. So you can see this relationship between work and these two properties of force and distance. Okay, so let's have a look at this first question. So question 1. So again, always when you're doing these questions, first of all, write down your formula. And then what you want to do is you want to identify what you have. So in order to use this formula, we need the force and we need the distance. So we have a read over the question, so we can see that a force of 10 newtons, okay, so that's the force, is being used to move an object a distance of 20 meters. So it's saying calculate the work done. Okay, so this is the formula that we use, and we just take the values from the question and we substitute into our formula. So it's going to be equal to 10 multiplied by 20, which is equal to 200 joules of work. Okay, so that's that first question. The second one then is calculate the work done when a force of 15 newtons moves an object a distance of 40 centimeters. So with this one, we need to take the centimeters and we need to convert it to meters. Okay, so again, we write down our formula. Work is equal to force multiplied by distance. Okay, so we know that the force is equal to 15 newtons, and we know that the distance is equal to 40 centimeters, but we need to convert that to meters. Okay, so we need to change this to meters. So what we can say is that 100 centimeters is equal to 1 meter. So therefore 1 centimeter, so we divide this by 100, and we'd have to divide this by 100. So 1 centimeter is equal to 1/100th of a meter. Okay, and if we put that into decimal form, so it's just going to be 1 divided by 100, and that's going to be equal to 0.01, which is equal to 0.01 of a meter. Okay, so 1 centimeter is equal to 0.01 of a meter. So there we want to find out, well, what's 40 centimeters? So we have to multiply both sides by 40. So we have to bring this up to 40. So we multiply it. So therefore 40 centimeters is going to be equal to 0.01 multiplied by 40. So let's have a look, multiply this by 40. And that's equal to 0.4. So 0.4 of a meter. Okay, so we've taken this and we've converted it into centimeters into meters. So then what we do is we just substitute the values into our formula. So it's going to be 15 multiplied by 0.4, which is going to be equal to 0.4 multiplied by 15. So it's going to be 0.4. Let me just check this. So 0.4 multiplied by 15. 0.4 multiplied by 15. So that's equal to 6, which is equal to 6. And that's going to be 6 joules. Okay, so 6 joules of work. 6 joules of work have been done. Okay, so they're the types of calculations that you could be asked in relation to if you've been asked to calculate work. So again, work is just force by distance. So let's have a look at some power then calculation. So power then is taking the work that's done and then determining like the time it took to do the work. So that's kind of like what we mean by when we're talking about power. So power then, if we write down our formula, so power is equal to work done over the time taken. Okay, so the work is going to be measured in joules. And the time is going to be in seconds. Okay, so joules per second. And the unit then is the watt. Okay, so that's the unit that we use to measure power. So the more work done in a shorter period of time, the more power you get. So if we have a look at this table, so again it shows the relationship between work, which is in joules, and time. So if we take the first one here, so it says that we have, so there's 100 joules of work that was done. So the time taken was 5 seconds, so therefore the power is 20. So where does that come from? So again, it just comes from the formula. So power is equal to the work done, which is going to be this here, joules, 100, divided by the time taken, which is seconds, and that's going to be equal to 20 watts. Okay, so if you have 100 joules and 5 seconds, done in 5 seconds, that's equivalent to 20 watts. If we have a look at, so this one here, okay, so just take one more and then we'll do a question. So again, you have, so power is going to be equal, you have 625 joules of work being done, and that's done over a period of 25 seconds. That's going to be equal to, when we divide it into each other, it's going to be equal to 25 watts. Okay, so that's the formula for power and how to calculate power. So let's look at an example of a question. So again, always when you're doing these questions, first of all, write out your formula. So power is equal to work divided by time. And then what you want to do is you want to, first of all, you have to get work, and then you have to get the time. So in this one, we're also going to need to calculate work as well. So work is equal to force multiplied by distance. Okay, so if we have a look at this, so the first thing we want to do is we want to get work. So it doesn't tell us what the work is, but it tells us the force. So a force of 10 newtons is being used to move an object 20 meters, and that's done in 5 seconds. So the first thing we need to do is we need to use these first two quantities to work out the amount of work that's done. So the amount of work that's done is just the force multiplied by distance. So you can see in the question it says that we applied a force of 10 newtons over a distance of 20 meters. So therefore the work done is going to be equal to 10 multiplied by 20, which is equal to 200 joules of work. Okay, so now we can use this then to calculate the amount of power that was produced. Okay, so power then is going to be equal to the work done. Okay, so the work done we've calculated is 200 joules, and that was done in 5 seconds. So that's going to be equal to 200 divided by 5. It's going to be equal to 40 watts. Okay, or another way to think about that is 40 joules per second, which is 1 joule per second is what's known as a watt. So 40 watts of power, 40 watts of power were generated in this activity. Okay, so that is the two quantities we've looked at are work. So the two quantities we've looked at are work and power. So again, work is done if a force results in an object moving a distance. Unit 1 joule is equal to 1 newton per meter, 1 newton by 1 meter, and that's what's known as a joule. So the formula is for work is equal to force multiplied by distance. The next one then is taking this and adding in the time dimension. So power then is the work done over a period of time. The unit is the watt or the joule per second. So power is work done over time taken. So 1 watt is 1 joule per second. So that is work and power.